So the final propagator last time I introduced is df x minus y, which is something like a time ordered 2-point function. And this can be understood as the theta x and 0, y 0. Y, and then plus theta y 0 minus x 0, 0 phi x, no, sorry, phi y. Phi x 0. Okay. And then this can be written as the integral form y 0 d cube p 2 pi cube 1 over 2 EP. Fine, and the e to the minus I p dot x minus y. And then also we put the p0 EP, and also the retarded one qp 2 pi cube 1 over EP. And here only sign changes because of, they just all swap the order x and y. So therefore here p dot x minus y, p0 minus EP. And the last time, so here the upper one, the first one, number 1 and number 2. Number 1, we just do the contour integral, something like a of this one. This explanation was okay. Like this way, EP minus EP. Do you have a question? Anyway, so this explanation was okay, so that the so if you take this one, you can add the p0 to pi I over p square minus n square e to the minus I p0 x0 minus y0 can be just manipulated into the following form. So this is C1 contour integral dp0 to pi I over p0 EP p0 plus EP e to the minus I p0 x0 minus y0. And you just pick the pole in here, and what you end up with the dp0. If you do the integral, and it can, so paying attention to the contour direction, what you get is that the 1 over 2 EP and the e to the minus IEP x0 minus y0. That was okay. That was okay. And then so the contribution from the this arc, this part, so this part, so this arc. So P0, imaginary part of P0 is minus I to the some big number. So if the radius is very big, let's see, order R. So the e to the minus I P0 x0 minus y0, and plug that one into here. Then it decays into e to the minus order R. So therefore, you can ignore it. And then the problem is that the second part, my explanation was not correct, and I will correct from now. So to do that, so let's copy and paste the second one. Copy and go to the next page. And I want to paste. Okay, good. This is the second one. Here, I would do the following manipulation. The P goes to minus P. Okay, then what we have is that the theta y0 minus x0, that doesn't change. D cube P 2 pi. Here, infinity to minus infinity, in fact, because of this change, And then 1 over e to EP, e to the I p vector and x vector, and times times e to the I EP x naught. Sorry. So here I miss y vector, x vector and y vector. So here it used to be, so this is the P0, x0 minus y0 minus P and x minus y. It used to be I times. But however, due to this change, now we have plus sign here. Okay. I think equal sign is missing. Okay. And after that, we can just do the following change, that the so you just look at the contour. Sorry. And big radius r. Then we just consider the following integral. Sorry. So I missed one explanation. So here it should have a minus sign. So P goes to minus P means the -1 to the cube, which is the -1. However, if you swap the integration order, so integration from minus infinity to plus infinity, you don't need, you can forget about this one. Okay, so that's one thing. Then we just include the dp0 integral as before. P square minus m square I e to the minus I p0 x0 minus y0. And this can be understood as a dp0 2 pi. And then again, we just manipulate p0 minus ep, p0 plus ep, I e to the minus I p0 x0 minus y0. Okay, now we pick the pole here because of this contour C2. And then we just look at this arc contribution. So arc P0 imaginary part is positive. And then in that case, the e to the minus I P0 x0 minus y0 is indeed equal to. So this quantity is negative, but because we impose theta y0 minus x0, so this quantity is negative. So if you multiply P0 is, if it is imaginary part, then the real part is order R. Okay, because this is negative and the P0 is the imaginary part positive, so minus I times I is positive, but the x0 minus y0 is equal to is negative. So therefore, this is negative. There's order R. So the arc part is does not contribute when you take the order R is very big, and then this is equal to EP e to the I e p x naught minus y naught. Okay, and this part is the same as this part. Okay, this part is the same as this part. So therefore, we can just plug p naught part inside of here as before, like this way. And at the end of the day, so what we get is Feynman propagator is before p square m square I e to the minus I p dot x minus y. Yeah, so this is should be the explanation of the y arc part does not contribute. I hope you understand it. Any question? Do you have a question? So the last time I skipped this the explanation of this part, this part. So and then I didn't swap the sign here. I didn't swap the sign here. So yeah, we didn't put the minus sign here. So that was a problem of the previous explanation. Yeah, so that is compatible minus sign here. So that is the part I missed. Any question? Apart from this Feynman propagator, do you have any question? It's I mean, I'm just using office hours. Oops, sorry. I just where did it? Go ahead if you have a question. Yeah. So it's a part of office hours. If you have a question, some other thing, it's okay. You can ask. So I will stop recording.